see some more properties of matrices. Okay, we will do multiply a matrix by a scalar. We'll do matrix addition, matrix subtraction, and multiplying two matrices. Okay, so let's see matrix. Multiplying a matrix by a scalar is an easy operation. We have already seen that. Where now this is an example where we multiply a matrix 1, 2, 3, 4 with 2. Then what we do, every corresponding element will be multiplied by 2, and it produces this matrix. Okay, 2 times 1, 2 times 2, 2 times 3, and 2 times 4. So now you see what is matrix addition. Okay, so when we try to add two matrices, they have to have identical dimensions. Okay, the number of rows and number of columns have to be same. So here let's see 1, 2, 3, 4, 5, 6 a matrix, and with that we add this other matrix, and we add 1 with 3, 2 with 4, 3 with 5 in that way, and corresponding to the second row also, and produces this matrix. Okay, so now you see matrix subtraction, which is very similar to matrix addition, and it also requires identical dimensions. That means the same number of rows and same number of columns of both the matrices. So we have two. In this case we have taken this one as A and this one as B, and when we multiply A minus B, so we have the exactly same, the corresponding elements 3 minus 1, 4 minus 2, the corresponding elements will be subtracted to create this matrix. Okay, so matrix addition is commutative, remember, like vector addition. Okay, A plus B equal to B plus A, but like vector addition, matrix subtraction is not commutative. Okay, so A minus B not equal to B minus A. If you subtract them in the different order, this will produce different matrix. Okay, so now you see matrix multiplication is a very, 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 very important item. Okay, so when we multiply two matrices A and B, so we have to make sure that they are in a particular structure. Okay, what is the structure? Number of columns in A should be equal to the number of rows in B. Number of columns in A should be equal to the number of rows in B. Now let's see this one. We have seen this one in our earlier video. So what we do, this is a coefficient matrix, and these are the x, y, z three variables. So what we have shown that the row items will be multiplied with the column item. That's why the number of rows and the number of columns in the corresponding matrix, they have to be similar, same. Okay, you see 2 in that order, the row of the first matrix 2, 5, and 3. 2 will be multiplied with x, that's the first step. 5 will be multiplied y, that's the second step, and 3 will be multiplied by z, that's the third step, and all of them will be added. You see, 2 with x, 5 with y, and 3 with z, and all of them will be added. Then minus 1 with x, minus 6 with y, and minus 11 with z, and then added, and in that way. Okay, so let's see an example. So A and B are two matrices. You see, number of columns in A, 3 columns, and number of rows in B are same. Okay, so A, B, when we multiply, we did exactly this row and this column is multiplied, and then this row and this column is multiplied. That's the second one. Then the second row and the first column is multiplied, and the second row and the second column is multiplied. Okay, so this produces the result 22, 28, 49, and 64. Here we have to tell you that matrix multiplication is not commutative. Okay, so AB not equal to BA. So if you change the matrices, let's say now we instead of AB we do BA, this one comes before. So what will happen? The row 1, 2 will be multiplied with the column. Okay, and then this will produce a 3 by 3 matrix. Okay, so 3 rows and 3 columns will produce a 3 by 3 matrix. In this example, we have 2 rows and 2 columns, so it produces a 2 by 2 matrix as a result of matrix multiplication. If we swap them, B comes before and then A. If we multiply BA, there will be 3 rows and 3 columns, so that will be a 3 by 3 matrix. It will be a different one. So we have now seen the multiplying matrix, the scalar, addition, subtraction, and multiplication properties. We also want to tell you that matrix multiplication is associative. So AB times C equal to A times B and C.